The derivatives. Start doing the derivatives, right? So you start with, oh, by the way, I don't like writing it arctan, and I would like to pretend I care about your feelings in this case, but I don't. So please write it tan, like inverse, please. Thank you. So for 10, that's the one you want to do? So we have f of x is equal to tan inverse x. Like this? You with me so far? So what's f prime of x? Because you're all awesome AB students, you know that immediately off the top of your head. What is it? So what is it? X squared plus 1 to the negative 1? Like that? Correct? So what's f second derivative? Negative x. Yeah, so you want to put it in front? Sure, we can do that, sure. Negative 2x, x squared plus 1 to the what? Negative 2. Let's just do one more for fun right now. What do you have to use at this point?
Product rule.
You got to use the product rule and the chain rule. Super exciting, right? So the derivative of the first times the second plus the first. Can you just tell, you guys have to help me make sure I don't make any simple mistakes here. I'm not done yet. Oh, I did that. When I'm doing this, kids, when I'm doing this, I'm calling that the first function and that the second function.
Yeah, you did it right for the.
Yeah, thank you. So ready? Negative 2 times x squared plus 1 to the negative 2 minus what? The derivative first times the second plus, I'm going to do this in 2 steps. I'm not going to do some of the simplification first, okay? Let's do it in a couple steps. I want to expand this a little bit slowly, okay? Because is it super easy to make mistakes on this? Yeah. Yes. The derivative of the first times the second plus the first, so it's going to be minus 2x times the derivative of the second, which is going to kick out a what? 2x times negative 2, right? Times x squared plus 1 to the what? Negative 3, right? So where did this all come from? Just so we're clear here. So this is the first function again, right? That's the first function. And then when we do the derivative of this, we're dropping down to negative 2. The 2x gets kicked out again. And then you have this being raised to the negative 3. Are you with me so far? Now, you've got to I'm writing it like this on purpose because what do you start seeing a lot of? You start seeing a lot of 2x's, right? You start seeing a lot of 2x's. So if we were to clean this up, let's clean this up a little bit. We have negative 2 x squared plus 1 to the negative 2 plus what? Plus 8x squared times what? X squared plus 1 to the what? Negative 3. Okay, so we've done. So we have f triple prime at 0 is going to be what? Is it negative 2? Yeah. Seems like it, yep. Plus what? F prime of 0 over 1 factorial times x to the first plus what? Not a rhetorical question, tell me. F double prime at 0 over x squared. So if we're going to estimate these things, let's look at 21 here. Let's look at 21. F of 0, what's the only thing you can tell me? There's no scale on this axis, right? So what can you tell me about f of 0? What's the only thing you can tell me? You know f of 0 is positive. That's all you can say for certain. Nice. Certain degree of positivity, right? F prime of 0 over 1. What can you tell me about f prime of 0 over 1? F prime of 0 over 1 factorial is going to be greater than, you know it's positive. Because the derivative here, it's increasing, right? The slope is greater than 0. The slope is greater than 0. So you know f prime of 0 is positive. A positive number divided by 1 is positive. Second derivative, that has to do with what? Concavity. This is concave what? Down. So concave down, what does that mean about the second derivative? Negative, right? So we can say definitively that this right here is f double prime of 0 is less than 0 because it's concave down. So over 2 factorial is still less than 0. So it's saying, what can you say about them? Well, you can say that A is greater than 0. You can say B is greater than 0. And you can say C is less than substitute. Yes, okay. So now we have the limit as x goes to 0 of 1 minus what? 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, all over what? X squared. What cancels? Oh, that goes away, right? So what does that leave you with? The limit as x goes to 0 of what? X squared over 2 factorial plus, oh, minus, thank you. Minus what? 4th over what? Times 1 over x squared, because you're dividing by x squared. Do things cancel nicely? They do. So what does it turn into? 1 over 2 factorial minus what? Over 4 factorial. Well, that's going to go to what? 0, leaving you with 1 over 2. Voila. Just looking at, you're literally just looking at these first terms right here. So what's that going to be? In this case, p is 3. So what you're going to end up with, 1 plus x to the third is equal to 1 plus what? 3x plus 3. I'm just going to write it out a little bit here. 2 factorial x squared plus 3 times 2 times 1, right? All over. Is that, did I get that right? Yeah. So what do you end up with? Oh, x cubed. Yeah, 1 plus 3x plus what? 3x squared plus x cubed. And then you're done, which is kind of cool. It's nice too because I'm changing it to, oh, I need to actually do that. Move it down a little bit. So I just changed one thing about the top one. Instead of e to the x, I made it I theta. Instead of x, I made it I theta. So in I is an I, like square root of -1, and theta is just a general theta value. Right now for me, just do the top one. What changes? What changes?
I probably want to make this n then.
Yeah. You can delete it. You can just like erase the x's. Yeah. Erase the x's.
But we still have to come up with that. We just gotta change x to like I theta, right?
Yes.
Because I squared is negative 1.
And then I squared
Negative I.
Negative 1.
but I squared
Is negative 1.
So just write out the first few terms. What do you get? I said only do the top one. So write it out. Clean that up, okay? Get rid of the pluses where there's minuses. Come on, clean up. Make the top row as clean as you can make it. You got it? Nice. Let's see. Do you do the first few terms? Izzy, just erase what you had. You see the sin x? Oh yeah, you can keep going. Okay, you've done that far. Okay, that's fine. Check it over, make sure it's right. What do you notice about the ascension of powers? Are all the powers represented? Do you have theta to the first, theta to the second, theta to the third, theta to the fourth? Are they all there?
I mean, they're in there.
Wait, where did I?
They should be there.
Was our
Because they disappeared.
In kids. Pinky, turn around. Izzy, turn around here.
Isn't I like -1?
Group 1 here. Can you move out of the way here? So yes, what is I squared? -1. The square root of a table times the square root of a table is a table. It doesn't matter what's underneath it, it can be negative. The square root of -1 times the square root of -1 is -1. So if you look at the top row here, they've written out the first few terms. So you get 1 plus I theta minus theta squared over 2 factorial minus I theta cubed over 3 factorial plus theta to the fourth. Okay, that is correct. Izzy, you can just come up and watch this right here if you can't see it.
It's the
I squared is -1. You have to remember that. Okay, so I'm going to change one thing again. I'm going to make it, it's a smaller thing this time. What happens, kids, watch, don't do, just watch. What happens if I put an I in front of the sign? What happens to everything on the left, on the other side? Yes. And what happens if I change x to theta instead? What's the only thing that happens? So these groups don't do anything. Watch what's going to happen here. So what do you do up there to all of the terms on the right-hand side of sine? They get multiplied by what? I. So if I multiply I over here, all of these get multiplied by what? So all of the odd power terms are going to get multiplied by I. Do you agree with that? And this turns into theta. So give me this right here. Where's the? Give me this one right here. So if we do this, all of these turn into what? They turn into thetas, right? Correct? And this turns into what? That's it was a theta, right? Because it was an x, right? So, and then the I comes in, so you have I, and I. You with me so far? What's the only thing that changes down here? All of these turn into what? Thetas. thetas. Okay, sit down everybody. You've done the bulk, I want to do the ending. And if you see it, try to be quiet so that you don't spoil the end of the movie for everybody. Are you with me so far? Do you see what we did there? All we've done is direct substitution. Are you with me?
Yes.
What do you see? Raise your hand when you see it. What do you see? What do you see?
I see I sine theta plus cosine theta.
Correct. So what you should see is this. E to the I theta is equal to cosine theta plus I sine theta. Do you see that? Add these two things together and you get that. Are you with me? All of these terms are here and all of these terms are here, no less or no more. They're all there. We have just proven this. Why is this super cool? What theta value do we want to plug in? Anybody have a suggestion of what theta value we should plug in? Well, it's true for anything, which is why this is super powerful, but it's one specific thing in this that is the coolest thing ever.
0.
We like 0, right? There's a better one.
1.
Better one,
-1.
pi. What's cosine of pi?
1.
Really?
Negative 1.
Thank you. What's sine of pi?
0.
So, what do you end up with? E to the I pi plus 1 is equal to 0. That's where it comes from. That's where it comes from. Let's just examine what this is. You have multiplicative identity, you have additive identity, you have irrational numbers, you have transcendental numbers, which you probably don't know what they are, but that's fine. You basically have like all these major fields of numeric existence all coming together. Like, let's just think about this. Infinite, irrational, transcendental, the basis for existence right here, an imaginary freaking number all coming together with 1 and canceling out to be 0. That's awesome. That is awesome. What did I tell you before? We take things that are really simple, spike them on the ground, break them into a million little pieces, and then all of a sudden you get really, really, really cool results. Really cool results.
That's cool.
That's the sexy scene math.
You presented that at an assembly one time,
Mhm.
during parents' weekend.
I did.
And my brother, he's now a freshman in college, but he's a year ahead of me, he's a year
Yeah.
ahead in math. And he was looking at that, and he spent like 30 minutes trying to figure out what the hell that meant.
Yeah, but that's what it means. So it is this thing right here. What's interesting, this is just a result of that formula, Euler's formula. Euler's formula. How do you spell Euler? E-U-L-E-R. E-U-L-E-R. Gotta use that. That is a spelling mistake I will take off points for. Like, I'll take off an infinity of points if you do O-I-L. If you ever want to troll a math professor, like, write that down. I studied Euler, and it was O-I-L-E-R. He's from Houston, Texas, and he... Kidding. Okay, is it 1 minute past?
Yeah.
Sayonara.
Alright, so tomorrow we still have 2 stories.